Because we have stretch, the
I love
technology.
I knew that I had stretch. I really want to use for a 1 hour form biology class. Besides that, though, they're like extra hard.
Like half an hour.
Yeah. Probably You look so pretty today. I mean, you always look pretty, but
I love you.
I like your outfit.
I like your
Thank you. I just had my hair done yesterday.
And it's on tape.
pretty.
It's on tape.
What?
Allie's comment, the nice comment to you, is now on tape.
Yeah.
It's going to be on the internet, on YouTube, so you can replay it and replay it.
I know if I'm having a crappy day.
So you can
Make
like
it
Thank you, Alex.
You can make it
your
yourself
ringtone. Yeah.
Yeah, right? Well, I almost got my bangs like yours, because that's straight across. So
You would look cute with that. I need
Mine
to
are
look
getting
cute
too
with
I
long.
think she
But I
looked
need
cute
to-
with anything, that's my opinion.
That's on tape too.
If she ever gets mad at you, just
Just
read
reset.
that.
Oh,
There you go.
Yeah,
I don't think we've ever even had a fight. I think
No.
we've elevated words, but
yeah,
fighting, no.
yeah, come on, yeah, right? Yeah,
I saw this thing on Facebook.
yeah, you can just see me like, yeah, right?
I was supposed to like fight.
Put your
I think she meant verbally.
Yeah, but.
Oh, okay.
If there's a verbal discussion, it's like, the carbon dioxide is sinking because of its density. Not because of its density, because of its temperature.
You're
But the temperature, no, anyway.
Don't you guys talk about singing?
It's funny because I was
That's all we talk about at home.
Oh, we're nerds.
Oh man.
I'm like a closet nerd too, because people look at me and they're like, oh, here comes another doodah. And it's like, no.
Actually.
Actually.
like walk in and like do this like crazy equation.
Okay,
Yeah.
speaking of crazy equations.
You just had to say it.
Yeah, I just had to say it. We combine all 4 variables. Pressure, volume, temperature, and number of particles into one single equation. And what we found was that equation looked whoops, those should be 2's. We found out the equation looked like that. And then what I told you was the magic of this. And why it's magic, I have no idea, but it's just the way that gases are, they're so regular, that when you take pressure times volume, divided by temperature, divided by number of particles, you always get 0.0821. So long as your volume is in liters, your pressure is in atmospheres, your temperature is in Kelvin, duh, and your number of particles is in moles, duh. Be careful about the liters and atmospheres, it will catch you, and if it catches you, you will lose points, right? And nobody wants to lose points because everybody wants as many points as they can get. Okay. Now the beauty of this, if we call this number here R, because, I don't know, gases are regular. I don't know why we call it R. That's a good enough reason for me to call it R. It really doesn't matter why it's called R. We end up with an equation that looks like this. PV over Tn equals R. Always true. Always. No matter what the case. And then you solve this guy out, and you get Pervner. The neat thing about Pervner is it's not comparing this situation with that situation. This is true of any gas in any situation. Take the pressure times the volume times the number of particles times 0.0821 times temperature. Make sure everything's in the right units, and the pressure times the volume equals the number of particles times 0.0821 times the temperature. Always. It's kind of neat. It has like a universal property to it. Another interesting universal property. Say you're at STP. What does it mean to be at STP? Okay, so standard temperature is 273 Kelvin. Nice. Nice. You guys didn't even say 0 degrees C, you just said 273 Kelvin. I love it. I love it. You guys are thinking in terms of Kelvin temperature. You should what you should do next time you have free time is you should convert 98.6 degrees Fahrenheit to Kelvin, and then next time you go to the doctor's office and they take your temperature and they say your temperature is 100, you're like, whoa, that's way off. It's supposed to be this. And if you took your temperature in Kelvin, it'd be like 320 something, and the doctor would be like 320 something. What are you talking about? Well, doesn't everybody measure things in Kelvin? Isn't that the scientific measure of temperature? And then the nurse, it just hypothetical situation. Anyways, if you want to mess around with your nurse, it would be a funny conversation. Yeah. Pressure. 760 torr. Perfect. Now, another magical statement. Oh, question?
I was like thinking about the R where you were talking about getting matter, but
You looked up why?
ideal gas content
The ideal gas constant is R, yeah?
is R.
Yeah, is there a reason why they call it R?
Be careful. It has different values depending on the units you're using for pressure and volume. No.
No?
Oh,
Okay.
no.
Oh, no. We'll go R for regular, right? Because I think it's funny to talk about gas and regularity at the same time. That's my thing.
There you go.
Okay, another fact at STP. Now think about this, remember, we have 4 variables here that we've been playing with for the past, well, basically all semester. We've been playing with these 4 variables talking about gases. What I'm telling you is we're at standard temperature and pressure, so our temperature and our pressure are fixed. The only other 2 things that we're concerned about are number of particles and volume. And here's the really neat thing. If you are at standard temperature and pressure, and you have 1 mole of any gas, 1 mole of any gas, let me underline any, doesn't matter what that gas is. You take that gas to standard temperature, standard pressure, if you have 1 mole, the volume is 22.4 liters, always. Always. No matter the gas, no matter the gas, that's all I can say. Because the temperature is fixed, the pressure is fixed, the number of particles is fixed. But guess what? The volume is also fixed no matter what. It actually relates to this Pervner equation. You can derive that 22.4 liters from the Pervner equation if you felt so compelled. Do you feel compelled? I feel compelled. Yes. Let's do it. Watch the magic happen. We're considering the situation that we have above. Temperature 273, pressure 760 torr, 1 mole of a gas, 22.4 liters. So what is our pressure? What is our pressure? We're subbing into the Pervner equation. What's our... Pervner equation. When you use PV equals nRT, you're taking advantage of R, and if you're taking advantage of R, you need liters, atmospheres, Kelvin, and mole. Why can't we sub in 760 for pressure? It's not in atmospheres. If you're going to use PV equals nRT, you're going to be using R, and if you're going to be using R, you got to have the right units. So 760 torr in atmospheres is what? 1 atmosphere. Pressure, 1. Yay. Volume, don't know. Let's assume we don't know the volume. I think it's going to come out to be 22.4. I sure hope it does, right? Because otherwise this whole chemistry thing's a house of cards, right? Number of moles. Number of moles, how many moles do we have? 1. Look at these beautiful numbers. R, what's R? The ideal gas constant? 0.0821. And what's our temperature? 273. So we have 1 times V, that's just V. And on the other side we have 1 mole, using our ideal gas constant, because gases act ideally for whatever reason, times temperature, 273. The result?
Wait.
No, you're good, you're good. Keep going, keep going. You're like our resident.
22.4.
22.4, yeah, woo! 22.4 liters. Boom. How cool is that? So, you give me a mole of any gas at STP, 22.4 liters. How cool is that? Question. At STP.
No.
What is the volume?
No.
I don't want it.
Me either.
At STP. What is the volume? Oh. Does anybody have a favorite element? We're gonna a favorite gaseous element? How about helium? Are we okay with helium? I like helium. Okay. At STP. Yeah, that wasn't very democratic at all, was it? I was like, hey, anybody have a favorite gas?
No, I'm
I like
just,
helium.
I'm just imagining the girl, like everyone thinking that you're at home, like, you know, sucking helium.
That's what I was just thinking.
Talking like, you know, a mouse.
And we know why helium makes our voice go, no? Let's explain this. Helium, go to the periodic table. Helium has a mass of 4 grams per mole. That's pretty light. What are we normally breathing in and out? Better yet, what are we normally, because when I talk, is it the air coming in or the air going out that makes the talking? Out, right? Because the air, like, I don't say anything. Well, I only say something when the air comes out, right? So what is it that's coming out whenever we breathe out? Carbon dioxide. What's carbon dioxide? Well, okay, carbon's 12, oxygen is 16, add it all up, 44 grams per mole. So you normally breathe out stuff that has a mass of 44 grams per mole. Now that's pretty heavy stuff compared to the helium. What was the O? What are you thinking?
I'm gonna go. I'm thinking that because helium is so light that when it's like going, because never mind.
Helium is so light that, yep.
Like maybe the vibrations like can move quicker because there's not as much like density and breakthrough.
When you talk, yes, you're on the board, or you're both on the right track. When you have helium in your lungs and you try to talk, you're used to pushing out 44 gram per mole particles, and they come out at the normal speed that they do, and your voice sounds normally like it does. When you put helium in there, which is 10 times lighter, it's coming out whoop, like that, like super fast, and as a result, your voice is coming out super high pitched. By the way, a gas that is also, you don't want to take in too much helium, because then your body's not getting oxygen, and then
Your lungs can freeze.
you're in a bad
It's really
situation.
cold. It's really cold.
Now there is a substance called disulfur pentafluoride.
Are you
No, it's sulfur hexafluoride.
There
That's
you
what
go.
it is. Sulfur hexafluoride. Sulfur hexafluoride. We can do the. This is interesting. It's about gases. It's about sulfur has a mass of 32. Fluorine has a mass of 19. Holly, on your calculator, if sulfur has a mass of 32 and we have 6 fluorines at 19, so 6 times 19 plus 32 is what?
Okay, 6. Wait.
6 times 19.
Oh my god.
You got it. I'm putting you on the spot, I know, but I appreciate this.
19 times 32.
Plus 32.
Why can't I do this?
Because I'm putting you on the spot in front of the entire room as it's snowing outside,
146.
as you're on TV. Oh, well, perfect. 146 grams per mole. Now, sulfur hexafluoride is also a gas. And if you can see where this is going, if you ingest this gas, now you're used to pushing 44 gram per mole particles out, and now you're pushing out 146 gram per mole particle, 146 gram per blah, blah, right? The helium comes out really high pitched, right? The sulfur hexafluoride comes out really low pitched. If you've ever seen the Saw movies, the voice of the Saw man is created by inhaling sulfur hexafluoride because it makes your voice sound so deep and it gets frightening. Right? Seriously. Don't even try it. We're not even going to try it. Check this out. We're going to listen to other people who have tried it. Seriously, this you will be. Can you what? Well, if you take too much helium and your body's not getting oxygen, if you don't get oxygen, can you die? Yes. Sulfur hexafluoride, can you die too? Yes. Now, why sulfur hexafluoride is actually scarier. Here's why. The sulfur hexafluoride is more dense than air, right? It's 146 grams per mole. Remember that Erica had that the bubble that blew up, and then the carbon dioxide sank because it was more dense. Well, the sulfur hexafluoride will also sink. So it will actually collect at the bottom of your lungs if you take too much of it. That's a bad thing, right? The helium, when you take it in, as soon as you open up your mouth to exhale, the helium is flying out because it's so much less dense than the air. Just like a helium balloon, it wants to, go up into the stratosphere. But the sulfur hexafluoride will actually settle in the bottom of your lungs. So when you do take in sulfur hexafluoride, you have to make sure that you do like deep breathing exercises to force it all out. Because otherwise, you have sulfur hexafluoride just sitting in your alveoli, clogging them up, and then you're not getting oxygen to your body. So yes, sulfur hexafluoride is actually more dangerous, but when done properly, it gets pretty awesome results. Let's see how awesome the results are. Oh, it always does this to me. I don't know why, but I'm not going to ask questions. It's okay. It still works. We're going to go back. Let's make sure we're still doing good on time. We're doing perfect on time. What? Oh, okay. There's. I was like, JK school? What is this? Just kidding school?
Jacqueline Kennedy Onassis.
Oh, is that what it is?
Yeah.
Oh, that's cool.
It's ABT school.
Sulfur. Oh, look at that. Sulfur hexafluoride, boys. This is going to be... Wait, hold on. The Mythbusters, come on, that's going to be fun. Everybody knows those guys. That's going to be more fun. This guy, this is going to be so much fun.
They're
my
great.
gosh. I can't wait. We keep on. I'm so excited.
We did now.
Advertisement. Fish and water.
Hey, Eddie. I brought your stuff. You don't have to go.
How long does it last?
Take care of you too.
You'll find out. You'll find out. Watch.
Best in class fuel economy. It's our most innovative ultimate ever.
It probably took multiple days.
That commercial made no sense.
Yeah.
This is sulfur hex.
Promise not to try it at home, okay? Okay. Now, everyone wants to know why my voice sounds higher when I inhale helium.
Well, several factors is that helium is 6 times less dense than air, which means sound waves travel through it much faster, which makes my voice sound much higher. Now, the same effect can be achieved in reverse if I inhale something like
Sulfur hexafluoride, which is 6 times denser than air. I inhale some of that.
Listen.
And my voice gets really low, and somehow I'm still fine. It's scientific!
That needs to be watched again. That needs to be watched again.
That was creepy! I had like nightmares tonight. From like creepy voices.
Okay. Our voice sounds how our voice sounds because of the air that's going past it and the speed that it goes past it and how hard our diaphragm is normally used to working. just like he said, with the helium, it's flying by so much faster, high-pitched. The sulfur hexafluoride is low-pitched, and gosh dang, is that frightening. Here we go.
That was awesome.
Oh my gosh.
That
Oh. I feel like I need to be sitting down.
Really cool. So you promise not to try it at home, okay?
Because it could collect in your lungs and you could die.
Why am I voice so higher when I inhale helium?
Well, simple fact is that helium is 6 times less dense than air, which means sound waves travel through it much faster, which makes my voice sound much higher. Now, the same effect can be achieved in reverse if I inhale something like
Sulfur
He's getting the
hexafluoride,
helium
which
out
is 6
by
times
breathing.
denser than air. I inhale some of that.
And my voice gets really loud, and somehow I'm still funny. It's scientific.
Amazing! Isn't that amazing?
That is awesome.
Yeah. Oh, whoa. No.
What are we getting into now?
Yeah, that's nothing.
A little risque.
Okay. Oh my gosh. Okay. Yeah.
Got Paige and Wolfie.
Oh, we'll sort that out at 5.
was cool.
Okay. Yeah. Doesn't that make you want to get some sulfur hexafluoride? You go online, you might be able to find it somewhere, but it could be expensive. I have no idea. Let's answer the question here that we were about to start going to. At STP, which at STP there's very regular things. If there's any one thing that you should remember, at STP, let me put an arrow here, 1 mole of a gas equals 22.4 liters. There's your factoid. This is another factoid to hammer into your head. At STP, 1 mole of gas is 22.4 liters. If you ever are suspicious of that fact, just run PervNerd and it's all good, it's in there. Here's a question, at STP, what is the volume of, we'll use helium, what is the volume of, what is the volume of 15 grams of helium gas? Now, the STP thing is good, because we know at STP, 1 mole is 22.4 liters. So if I know how many moles I have, I know how many liters I have. If I have 15 grams of helium, does that tell me how many moles of helium I have? No. But, can I find out how many moles of helium I have? Yes, I got that off the periodic table. Well, the periodic table that I have memorized in my head, but it's on the periodic table, trust me. So, 15 grams of helium. Let's convert. There are 4 grams of helium for every 1 mole of helium. Remember, the grams is going to go on the denominator, so the grams cancels with the grams, right? The fancy word for that, by the way, with the units canceling, is called dimensional analysis. If you want the fancy word. I don't like the fancy words because they cloud what's going on, but if you want to talk about that, you can be like, today in class I learned about dimensional analysis. And parents are like, wow, what does that mean? Well, unit on top, unit on bottom, they cancel. Right? So, go through the thing. How many moles of helium do we have? It looks like about 4. Oh, actually, we can do that one in our head. That's 3.75 moles of helium. Just 15 divided by 4. But the question wasn't how many moles of helium we had. The question was what was the volume. But we're at STP. So each mole is 22.4 liters. So we have 3.75 moles. Watch this. 3.75 moles of helium. Do the conversion. 1 mole of helium. 22.4 liters helium. That is a fact. It isn't equation, it's equality, right? And anything that has equality, we can set up as a conversion factor. Just like 12 inches is 1 foot. And guess what? Moles cancels with moles, and now we're left with liters. It should be, if we had about 4 moles, it should be about 4 22.4 liter amounts. I'm guessing it's around 80. Yeah, 84.
Good job.
So, what did we learn today? 1, PervNerd is useful when, and PervNerd is useful, and PervNerd is always accurate when you have the right units. Remember, we almost screwed that up. I asked you guys, what was pressure? And you said 760. In PervNerd, you've got to have the right, units in order to use the R value of 0.0821. Now, what we also use PervNerd to show is that any gas, 1 mole, STP, 22.4 liters, always. So that allows us to find out how much of something we have. Give me 15 grams of helium, put me at 0 degrees Celsius, put me at sea level, 84 liters. That's 42 2-liter bottles. That's a lot of helium. That's a lot of high voice talking, which is something we also learned about, right? When the air travels faster past your voice box, this is a physiology thing, but that's okay. The helium makes your voice go higher. Sulfur hexafluoride makes your voice go lower to the point where you sound frightening, right? Any questions on this? Because where's my clipboard? Are those chasses?
Yeah, I guess.
Mr. Blythe.
Good count them as like shuffles.
Shuffles? Okay, I'm comfortable with that. Oh my gosh. We are knocking on chapter 11's door here. We're almost through. So tonight I'm gonna have to sit down and put together a homework assignment for you guys. Probably due on, let's see, today is Thursday, so the homework will probably be due on Tuesday. And we'll probably have a test next Thursday. Let me put that on the board so that it's official. It's official. We have our chem test on Thursday. And it's over gas and regularity.
Mr. Black, would you just email me the homework tomorrow? Then I'll have it done by then.
Give me 1 second to write this down first, and then I will make a note of it.
Okay.
Next Thursday?
A note has been made. Next Thursday, you said?
What?
Yeah.
No,
What did you
email me the
say?
homework tomorrow.
You need it emailed to you?
Yeah, I won't be
Because
here.
Allie's not going to be here tomorrow.
I can always text you the problems.
Yeah.
You could do that.
Any of us
That
could
would
do
work
that.
too.
Wait, we got it sorted out here?
I think so, sure. As long as somebody sends me some problems.
I'm comfortable with that.
Okay,
You're fine,
just
honey.
just give us a text or
Yeah,
something if you
okay.
need it.
Yeah, yeah.
Just text message.
Lauren will come through because she's good with the details. Seriously, Lauren, your detail attention is unusually good.